Hi there. So here we're looking at solving basic equations and just the idea of working backwards through order of operations. So to solve equations, the foundation of solving equations is just working backwards through order of operations and then undoing the operations as we go. So just a reminder, order of operations, I look at it as Irmdas. And I always write it like this. We stack it, and part of that is to remember that there are ties between like multiplication and division in terms of order of operations. But also, if we're working backwards through this process, that means we're going to undo addition and subtraction first. Then we're going to undo multiplication, division. Then we would undo exponents and roots, which we don't have the skill for quite yet, and then we'll undo inclusion symbols, okay? And to undo operations, we use these inverse operations, which are the things that are stacked here. Like to undo addition, I use subtraction. To undo multiplication, I use division. To undo division, I use multiplication. To undo subtraction, I use addition. So that idea of using the opposite. And yeah, you probably figured out to undo exponents, use roots. To undo roots, you use exponents. Again, we're not quite there yet. That's an Algebra 2 thing, all right? But again, we're just working backwards through order of operations, and then we're using that opposite or inverse operation as we go, okay? So we undo addition and subtraction, we undo multiplication, division, then we'll undo inclusion symbols. For example, if we look at something like this guy, I have two operations happening here. Hopefully you see the operations. This is 2 times x and then plus 1. So I have a times 2 and I have a plus 1. But instead of actually doing the operations, I want to work backwards through those operations. So I want to undo addition and subtraction first. So I want to undo the addition before I undo that multiplication. So to undo addition, I use subtraction because that's the opposite. So to undo a plus 1, I do a minus 1. And one of the other things we have to remember with equations is we have to keep it balanced. Whatever I do to one side, I have to do to the other side. Okay? And so what happens is a plus 1 and a minus 1 cancel each other out, so I'm just left with the 2 times x. And then on the other side, 7 minus 1 is a 6. And now to undo multiplication, I have to do the opposite of multiplying, which is dividing. So to undo multiplying by 2, I divide by 2. And whatever I do to one side, I have to do to the other side. And so over here, the times 2 and divided by 2 cancel out, so I'm just left with x. Over here, 6 divided by 2 is a 3. And that's it. If I look at the next one, I have division. Remember, that's what a fraction bar is. So I have division and I have addition. So if I'm working backwards through order of operations, I undo addition first. So I have to get rid of the addition first. So I undo addition by subtracting. So to undo a plus 3, I do a minus 3. Whatever I do to one side, I have to do to the other side. And so once again, what happens is these guys cancel. So I'm left with x divided by 4 equals negative 2 minus 3 is a negative 5. And now to undo division, I have to use the opposite operation, the inverse operation, which is multiplication. So to undo dividing by 4, I multiply by 4. Whatever I do to one side, I have to do to the other side. So then once again, over here, the multiplication and division, well, those guys cancel each other out, okay? Divided by and times, they cancel each other out, so I'm just left with x. Over here, negative 5 times 4 is a negative 20. Okay? If I look at the next one, I've got 1/2 x minus 4. So again, I have to undo these operations. I have to work backwards, so I undo addition and subtraction first. So I'm going to undo the subtraction. To undo subtracting 4, I'm going to add 4. I do the opposite operation, all right? To undo subtraction, I use addition. So here they cancel. So I have 1/2 x equals 9. And now to undo multiplying by 1/2, you might say divide by 1/2, but remember, multiplication, a fraction, is just a division sign. So really, a times 1/2 is really a divided by 2. So I'm going to multiply each side by 2 to get rid of that. See, because right here, the times 2 and the divided by 2, that's what this fraction bar is. These cancel out. So I'm left with 1x, which is really just x. Okay? So anytime you see a fraction, you can always think of a fraction as division, and we can get rid of division by multiplying. And of course, that's an 18. Okay? For this guy, this is a little tricky. When we see these fractions, just think of it as two operations, probably the easiest way to do it. Remember, a fraction is just times the numerator divided by the denominator. That fraction bar is a division sign, so it's times 3 divided by 4. okay? And so if we're working backwards order of operations, it doesn't matter which one we undo first, but because I don't like the fraction, I don't like the division sign, I'm going to undo the division first. So again, if you think of that fraction bar as divided by, this says divided by 4. So to undo dividing by 4, I'm going to multiply by 4. And whatever I do to one side, I have to do the other side. So then the times 4 and divided by 4, these cancel each other out. So I'm just left with 3x. Okay? And then over here, 6 times 4 is a 24. Now I can undo the multiplication by dividing, so I divide each side by 3. So I get x equals an 8. That's it. If I look at the next one, again, if I'm strictly working backwards through order of operations, right here I have two main things happening. I have multiplication, so it's 3 times whatever is in these parentheses, but then I have inclusion symbols, so I've got the parentheses. And so if I'm literally working backwards through order of operations, I would undo the multiplication first by dividing each side by 3. And again, the times 3 and divided by 3 cancel out. Now I'm only left with what was in the parentheses, so I can undo what was in the parentheses. It just so happens that what was in the parentheses is addition, so I undo it with subtraction. Okay? And that is not the only way to do this one. If you remember the idea of simplifying and then solving, you could have distributed the 3 first, and if you feel more comfortable distributing the 3, and then solving by undoing the addition with subtraction, and undoing the multiplication with division, well, that is fine, just fine, because you get the same answer. Okay? If I look at the next one, again, there's invisible parentheses here. It's x minus 6 divided by 7. So that whole thing, this entire numerator, this whole thing is divided by 7. All right, so that's in parentheses, so I have to undo the division first. Then I'll undo what's in the parentheses. So I undo dividing by 7 by multiplying by 7. I undo division with multiplication. So once again, the times 7 and divided by 7 cancel each other out. Over here, that gives me a negative 49. And now I can undo what was in the parentheses. It happens to be subtraction, which I undo with a little bit of addition. Okay? That's it. If I look at the next one, once again, there's invisible parentheses hanging around here. This entire numerator, the 2x plus 3, this whole thing is being divided by 5, which means that whole thing is in parentheses, okay? So I have to undo the division, then I'll tackle what's in the parentheses. So to undo dividing by 5, I'm going to multiply by 5. Again, make sure you do it to each side. The times 5 and divided by 5 cancel each other out. So now I'm just left with what was in the parentheses, the 2x plus 3. So if I'm looking at what was in the parentheses, I have multiplication and addition. Well, again, I work backwards, so I'm going to undo the addition first by subtracting. And now I can undo that multiplication by dividing. And I end up with an x equals 6. Okay? And again, I didn't show it here, but these cancel out. These cancel out, and that's why we're doing those specific operations. We're doing the thing that will get rid of that guy. We're doing the opposite so that it cancels out. Okay?